Welcome, everybody. I'm Greg Ostrovich. Welcome to the combined Denver and Boulder Java User Group meeting. Reminder that we're always looking for DJUG speakers. Reach out to Matt Rabel or myself, or send a message through the meetup if you're interested or you have a speaker topic you'd like to see us cover. Housekeeping announcement: if you need to use the restroom, hopefully you can find it in your house or wherever you're watching this stream. Tech Systems is our food sponsor. We appreciate their support. Tonight's dinner is sponsored by your pantry and whatever's in your fridge. Our Tech Systems contact is Courtney Elterman, which is celterman@techsystems.com. You can see her in the rolling slide deck that we do. We appreciate their support. If you're looking for staffing needs, reach out to them and some of our other sponsors. JFrog is another sponsor, and they've been doing some really great giveaways. We'll do a QR code or a bit.ly link in the chat so that you can do that. And Ari Waller is our contact there, and we really appreciate JFrog and what they do for our members of the JUG. Apex Systems is our beer sponsor. Tonight's beers or other adult beverages or just soda or water are sponsored by whatever's in your fridge. Tonight I'm drinking Leinenkugel that I had picked up. We appreciate Apex Systems. Braden Collip is our contact. Reach out to them for if you have any staffing needs, and you can see him on the slide on our rolling deck. Develop Intelligence is another sponsor of the Java Users Group. They give away a Pluralsight, which is a training website. It's really awesome. We did some stuff with it for work. It's a lot richer than I realized. And Ace Van Wanseel is our contact with Pluralsight, with Develop Intelligence, I'm sorry. They're always looking to hire technical instructors who specialize in various technologies and in contract opportunities. Those include Java, Golang, JavaScript, React, DevOps, tools like Kubernetes and Docker, and many others. Also reach out to Bob Clary, bob@developintelligence.com. Amazon is another sponsor that we have, and they have a lot of different opportunities, full stack development, some DevOps stuff, front-end web engineers, web developers. So check them out if you're interested. Chris Almond and Sam Ayer have been our contact, and we thank them for their sponsorship. Okta is responsible for our meetup site, our online meeting, a broadcast that we're doing right now, as well as some other stuff, and we thank them, and we especially thank Matt Rabel for putting all of that together. NextGen is another sponsor, and Dana Estlund is our contact there, and they're another staffing agency. They recently had a full stack mid to senior Java developer opening, and that position used Angular. Check their website for details. Another sponsor is Agile Learner Venkat Subramanian. We love them. They're great. They're going to put on a conference. It had to be rescheduled with COVID, but we'll look forward to details on that when it comes up. Go to agilelearner.com. They have all sorts of training and great information. Another sponsor is JetBrains. For quite a number of years, at least probably 10 years, they've been our sponsor, and we give away a free IDE, and Mike Zwedel will handle that, and you'll see that in the chat. But we really appreciate their sponsorship and continued support. So a quick shout out to the DJUG board that helps run the Denver Java Users Group, and that is Matt Rabel, who handles speakers, locations, the broadcast, Mike Zwedel, who's been doing the door prizes, Zeddy Chinfang, who does operational stuff, including social media, announcements, etc. This happens because of all of those people. I get up and talk, but they do a lot of the hard work, and I really appreciate it, and I want to thank them. So now I'm going to bring up Chris Woina from the Boulder Java Users Group. He has a few thank yous he'd like to make, and here's Chris.
Thanks very much, Greg. So first of all, we are also sponsored by Tech Systems. They're America's foremost technical recruiter, and we're working with James Corboy. So anywhere north of Denver, if you have any interest or just want to find out about what's going on, contact James or contact me, and I'll put you in contact with him. We've been fortunate to have been meeting pre-COVID and hopefully after COVID at Rule 4 Cybersecurity and Emerging Technologies. They were a 2019 Colorado Technology Association winner, and I think they were this year's CEO winner. No Fluff, Just Stuff, Jay Zimmerman, they put on world-class conferences, and they have an upcoming UberConf in October, I believe. Venkat Subramaniam and his Agile developer website, JetBrains, IntelliJ, and also O'Reilly Books. If you're interested in our door prizes are video learning from Agile developer or a JetBrains IntelliJ license, be the first person to contact me through the Boulder Java Users Group meetup website, and you'll get that from me. Back to you, Greg. Thank you.
All right. Thank you, Chris. Also, just a heads up, we're talking about maybe deferring our July meeting, so we will let you know. We might take off for July, but we will keep you up to date, and we'll get out the announcements for our June meeting, and as our usual schedule permits. So just a heads up on that. So tonight's presentation is how and why to upgrade to Java 16 or 17. Java upgrades are sometimes seen as difficult, and many applications are still running on an older version of Java. My stuff's running on really, really old Java. This session describes Java's current 6-month release process and why applications should use a recent Java version. After this, our speaker Johan will explain the challenges of upgrading and providing some useful tips to make the process easier. Some concrete examples, including solutions, will be used to show you how to upgrade your application to Java 16 or 17. Tonight's speaker is Johan Janssen, and it's 1 a.m. there now, so thank you so much for doing this talk tonight, Johan. Johan is working as a software architect at Sanoma Learning. He has been working for various demanding companies where rapidly delivering high-quality software was very important. Johan regularly writes articles and presents about various subjects, but mainly around Java. He has spoken in 20 countries at more than 40 different conferences, such as JavaOne, GOTO Amsterdam, /Berlin, /Copenhagen, Devoxx BE, UK, PL, JavaZone, Jfokus, JavaLand, Scala Days Berlin, New York. Johan received the JavaOne Rockstar and Oracle Code One Star Awards as well. You can find Johan on Twitter at Johan Janssen 42, and we'll put that in the. I'll put those in the meetup if you're trying to reach out to him. So thank you so much, Johan. We're really looking forward to this talk tonight. Thank you for joining us, especially at this rather odd hour, just because of the time difference.
Yeah, thanks a lot. If I knew that you would have to read up my entire bio, I would have sent the short version.
It's all good. Thank you so much again for speaking. I'm really looking forward to this.
No problem. Thanks a lot. So let's get started with how and why to upgrade to Java 16 or 17. I actually also have a couple of links to share, but I see that I have to figure out how to do that later. So let's first start with the presentation. Short agenda, basically, on what we will cover. If you have any questions, please feel free to simply interrupt me in between. Simply start talking and ask your questions. You don't have to wait until the end. Afterwards, we can, of course, continue the discussion. But again, feel free to interrupt me. If you have any questions later, feel free to contact me through Twitter or through LinkedIn. And I think the most interesting link for this is my GitHub repository, where basically a lot of the information that I'm explaining in this session is also documented. Okay. Give a quick overview of that. Let's put it on the right screen. And so basically what I did is I created a Git repository with some examples, which we will cover later, and a lot of documentation. And here you can, for instance, see what kinds of errors you might get, and also the solution to fix those errors. and that's then based on every Java version. So this will hopefully help everyone to make the upgrade process a bit smoother. And in this presentation, I will discuss some of the things that are also documented here. Slides are also online, so you don't need to make a lot of notes. I will later also share the link to the slide deck. A bit of background. I didn't create this presentation and the guide based on a lot of Googling. It's basically based on years of experience upgrading to Java 8, 11, and now 16 and 17. Still with a lot of Googling, of course, because every time you encounter some errors, you have to figure out what's going on and how you have to fix it. And like mentioned, I already did quite some upgrades, and I also got some feedback from colleagues and other people to improve the slide deck and to improve the examples. And the other presentation I gave today, I again got some good feedback, which I managed to incorporate in this slide deck again. So if you have any comments or feedback, please let me know. In the end, I think it's the intention is to help everybody get a smoother upgrade process to get to the latest version of Java. But why should we actually upgrade? I think there are a couple of good reasons. You get some free improvements like performance improvements and security fixes. But you also can use all the cool new features such as Java records and pattern matching. And I think nowadays it's quite hard to attract and keep employees. There are a lot of positions available. And I think, yeah, if you can promise them to work in a bit of a new environment with a new version of Java and new tools and frameworks around it, I think that might help as well. So I think there are various reasons why it's good to upgrade. And why would you maybe not upgrade? It is quite a bit of work, depending on how your environment looks like. Yeah, you have to update your local machine, the build environment, production and test environments, etc. That can be quite a bit of work. And I think a lot of people are still on Java 8 and they are a bit scared of Jigsaw, the Java 9 module system. And a lot of people think that it's a lot of work to use the module system. Actually, it can be quite a bit of work to use it, but the nice thing is you don't need to use it. So you can simply upgrade to Java 9 and not use any of the module functionalities. If you don't need it, it's perfectly fine to not use them. So you don't have to be afraid for that. Another reason I regularly hear is that some applications need to run on machines from your customers. And maybe they still run on old versions of Java, or your customers have various versions of Java installed. That can also be a challenge, and it's a bit harder to upgrade because you still need to support the old versions of Java that are still running for your customers. Actually, nowadays, there is a bit of a solution for that. You can use the multi-release jar feature, which was introduced a couple of Java versions ago. And with that, you can incorporate various Java versions in one artifact, so in one jar file, for instance, which is quite cool. So we have the Java package, so source main Java, which you probably are familiar with. And then we have an application and student class in there. And we have a Java 17 folder with the same student class, but with a different implementation. So how does this look like? Let's show some code with it, because that hopefully makes it a bit clearer. So we have the application, which basically retrieves the information, such as what the Java version is that's running currently. A student is created, and we check if the student name contains a blank character, and we do that for two different students. If we then look at the student, this is a plain Java class. You're probably familiar with it, with some ugly code inside it. We retrieve if it's a Java class, the info, and this is the code that we use to check if the name contains any blank characters. So this is regular older code in Java. Now in the Java 17 folder, we have the same file, but this time it's actually a record. So it's a cool new feature basically. And the check for isBlankName is now the string.isBlank, which was also fairly recently introduced in Java. So we have two different versions of Java code within our application. If we then look at our POM file, we need to configure some things for this to work. Basically, we say that we want to compile the regular stuff with Java 8, so everything underneath the Java folder. And then we specify that we want to compile the rest with Java 17, and we specify that all the Java 17 code is underneath the source main Java 17 directory. There's a bit more configuration for my jar file as well to make sure that it can start automatically. And this is the way how you can use multiple versions of Java inside one application. If we then look how we can test this and how we can actually show this is really working, what we do is we use a Docker file and we build everything on Java 17. So you need to build it on the latest version you use. In my case, that's 17. I add the source code, I package the application, and then I basically run the java-jar from the jar file on Java 17. After that, I do the same, but then on Java 8, and then again the same, but on Java 11. Let's quickly grab the command because I'm a bit lazy to copy paste it, to type it, I mean. And execute this one. So now this is being built, the jar file on Java 17, and then we run the application on Java 17, Java 8, and Java 11. Let's make this a little bit bigger. Oh, I think I'm in the wrong folder. It's doing way too many things now. Let's not do that for now. And of course, I changed something so my caching doesn't work, but luckily the internet is fast enough. So it's now quickly downloading all the Maven artifacts that I need. And the application is being built, and it will be running in a few seconds. So let's scroll up a little bit. So the application is built, and here the application is being run on Java 17. So we see the version of Java which is being used, 17 early access. We see that it's actually using the Java record feature, and the other tests are printed as well. If we then go down a little bit, we see on Java 8 it's running the Java class, and we can see again the same results there. Java 11. Again, the Java class and the rest of the stuff. So basically, on Java 17 or higher, this code is used. On everything below Java 17, this piece of code is being used. So that way you can incorporate multiple versions of Java within one jar file. One thing to keep in mind is that it's a little bit tricky because if your student class, you basically have two student files, and if one contains a public method, which the other doesn't contain, and you try to call it, then of course it breaks on that version of Java where you use that functionality. And actually, if you use Maven, Maven won't complain about that. Maven will simply build everything. But I noticed that the IDE will complain and give you a warning when you try to use a method that's not available on each version of the Java implementations that you created. So that's something to take into account. And I also think that it's a nice feature to maybe build a couple of features. But if you build your entire application this way, then of course you have to duplicate or even build everything 3 times. On each version of Java, so that will be a lot of maintenance. But if you want to use a couple of features, maybe because they have a lot of performance benefits in your application, then you can easily do it in this way. So it's a nice and interesting thing that's added to Java. For the other things, if we want to upgrade our application, we also have to upgrade our build environment and our production environment, etc. And there, if you use Docker, that's fairly easy. You can simply update the base image you use in your Docker file and use the latest version of Java in your build environment and in your test environment, etc. If you don't use Docker and you still have a build environment on bare metal or in a virtual machine, you need to make sure that the new version of Java is available there as well, and probably that you also still have the old version available so that you can still build your application and deploy it to production if you need it. So that's a bit more work. So I definitely like using Docker for this. We're doing it within our company now as well. And basically teams can decide per application when and how they want to migrate to the latest version of Java. They don't need to manage something centrally in build servers. It's all abstracted away by using Docker. So that's a big benefit for us, and it streamlines the upgrade process. So why actually this session? What I've noticed is that a lot of people think that upgrading is quite a challenge, and there is a lot of things that are unknown, so it's also really difficult to estimate how much of a challenge it actually is. And a lot of projects still stay on old versions of Java. Recent polls indicated that still a lot were on Java 8 or older. And what I find interesting is that for me, the upgrade itself, the technical changes that you need to make, I think aren't even the biggest challenge. The biggest challenge is to convince management or the business to spend time on this. What I came across was that teams basically estimated weeks or months for the upgrade process because they simply didn't know what they needed to do exactly. And that was for an upgrade from Java 8 to 11. When I did that upgrade for the team, I managed to do that in a couple of days. And that was partly because I have previous experience, but it's also partly that you just need to get started with things like this. It's hard to estimate, and if you give a really high estimate, business will postpone it because they don't have the time for it. And so it's typically something I like to do on a Friday afternoon when my hours are finished or nearly finished. Try to upgrade the application, try to run it on a new version of Java and see how many issues you encounter and see how far you can get in like an hour. And maybe you even fix a lot of those things already in the first hour, and it gives you a good impression about how much time you need extra to do the rest of the changes. Of course, it's still a matter of doing, and you encounter issues as you progress, but it gives you a better feeling once you get started. So for me, that's, I think, the biggest tip. Basically, just get started with it and try to upgrade. I've seen a lot of applications where actually it was fairly easy to upgrade, especially if your dependencies are up to date, or if you use something like Spring Boot, which manages your dependencies, and upgrading to a new version of Java is fairly easy to do. Actually, I recently upgraded applications from 11 to 16, and there I only needed to upgrade Lombok, and for the rest, I didn't need to make any changes. So don't be too afraid of the upgrade. It's not such a big challenge. Of course, it depends on your application, but it's quite doable in my experience. In the past, I've also upgraded JSF for the ones who are familiar with that. Only minor upgrades were already a huge challenge. I think upgrading Java is a lot easier than that. So I tried to give you some tips because a lot of the challenges that I came across while upgrading various projects were the same across all of those projects, or at least recurring in some of them. So I hope that I can share those with you so that you can use them already to upgrade parts of your application, and then you can focus on fixing the challenges that are specific for your application. I use Maven as an example, but of course you can use Gradle or any other build tool that you want. So let's go on this journey together, because I hope it's more fun, and at least it will also make it easier for everyone to learn from the experience that I and colleagues already had. So if you look at Java, before Java had a new version every 3 years or 4 years, at least every couple of years. Nowadays, there is a release every 6 months. And every 3 years, there is a long-term support or LTS version. The latest LTS version is Java 11, and the next one, Java 17, will be released in September 2021, so this September. For me, the biggest difference between those is that for the normal version, so Java 12 until 16, they only receive support, so they only receive minor updates for 6 months until the next major Java version is released. The LTS versions, they receive updates for a way longer period of time, at least until the next LTS version is released. And it depends a bit on the vendor whose JDK build you're using, how long it actually is supported. So you have to look it up on the documentation from your vendor. And then I think there is an important decision to make. Do you want to stay on LTS versions, or do you want to use the latest versions? Like I already mentioned, the non-LTS versions only receive updates for 6 months. After that, you need to do a major upgrade from a major version to make sure that you again can use the minor version upgrades. So if you're unsure if you can spend a bit of time every 6 months to do the upgrade, it might be a bit risky to use the latest version because you need to regularly update for that. On the other hand, if you use the LTS versions, then a lot has changed between those LTS versions, and upgrading something is more of a challenge. For our company now, we recently migrated to Java 11, as I recently joined the company. And we decided to stay on LTS versions for now, also based on the fact that the most interesting new features were records and things like pattern matching for us. And then they were released in Java 16, so it was a fairly short period of time until Java 17. If Java 18 maybe includes really awesome features, we might revise that strategy and use Java 18 when that's released. So for us, it's a bit of see what the pros and cons are, and then look at what's included in the Java versions and how much time our teams have to keep it up to date. Personally, I of course prefer to stay on the latest version, makes upgrading a lot easier. And you can use all the cool new stuff already when it's released. If we want to upgrade, then what do we need to upgrade? Typically, our application consists of some application code that you wrote yourself or your colleagues, and some dependencies on various frameworks, such as Spring or whatever frameworks you have. All of that runs on Java, on the JDK, and in a new version of Java, some stuff might be removed from the JDK, which means that maybe your dependencies need to be changed, your application code needs to be changed, or both. There, it sometimes helps to be a bit more patient. If your dependencies don't support the newest version of Java yet, you can of course try to fix that yourself. You can also wait until they release a new version with support for the latest version of Java. Then you just have to update your dependencies and you're good to go. If we talk about deleting features in the JDK, most of the time it's not actually deleting. They start with deprecating something, so they mark it for deletion, and later something is actually deleted. For instance, if we look at JavaOne BE, it was a normal Java feature until Java 8. In Java 9 and 10, it was deprecated, and in Java 11, the feature was actually removed. So if you update every version of Java and stay on the latest version, then on Java 9, you already get a warning that you use deprecated stuff. You can fix that, make sure you no longer use the deprecated items. And then when you migrate to Java 11, you don't actually have an issue because you already fixed it along the way. If, on the other hand, you migrated from 8 to 11 directly, then of course you get all kinds of compile errors because things can't be found any longer. So what's actually removed within the JDK? It can be basically anything. So I created a short list of various things on this slide. But it can be anything from methods to basically configuration options or even complete tools like Java Mission Control. If you really want to know the details about that, you can look at the JavaAlmanac.io website or the Fuji version of the Java Almanac, where for every method and every detail you can see in which version of Java it is added or removed or marked for deprecation. So this has a lot of detail in it. But don't worry, you don't need to remember this by heart. Actually, I only noticed this one after I did a lot of upgrades myself, but it's sometimes helpful if you try to run an application and you get strange errors, that you can look up in the Almanac whether things have been removed or changed in the recent versions of Java. So it's more like a reference which you can use. Some other detailed information is available on the OpenJDK website, which describes the new features in Java, and in the release notes from Oracle. So let's quickly show that, because I think that might be helpful. So if we look at JDK 17 on the OpenJDK website, we can see all the higher level features that are being added or removed or marked for deprecation. So this has a lot of detail. Already you can click through for a lot of more information. You can change this to another version of Java to see it for another version. So if you encounter any issues when upgrading to Java 16, you can look at the new features and see what has changed in this version and figure out what caused the issue for you. The same goes for the release notes, which Oracle released. These go a bit further and show even more detail on what's being added or deprecated, such as in this case some arguments for Java and some certificate information. So again, a lot of reference information that might come in handy someday if you want to dive deeper in this. So this is the Almanac website where you can click through for a lot of information, and the same goes for the Fuji version of the Almanac. So I think some interesting information, but I wouldn't recommend trying to remember all of that, because it's a lot of information. So when you work on upgrading your Java version, you probably want to run multiple JDKs at the same time. You want to run the old version because you still want to work on the old version of the application and deploy that to production or make bug fixes and stuff like that. And you want to run the new version of Java to do the actual upgrade. There are a couple of options to manage that. If you use Maven, you can simply change the Java home variable, and based on that, Maven will pick that version of the JDK that's in the Java home variable. You can use the Maven tool change feature, which allow you to specify which version to use in the POM file. But I came across some issues with that at the moment, so I will dive into that a little bit later. You can use SDKmon to manage the versions of Java installed on your machine, or you can use Docker. I think Docker is nice as an abstraction layer, and for instance, to test after you finished your migration, to test in a clean environment if everything still works properly, to make sure there is no strange configuration which is only running on your machine and it works on your machine. But for the actual upgrade process, the feedback loop is a bit long, because you first need to add your application code inside a Docker image and then run it. So it takes a bit of a time before you know what's going on. But it can be quite helpful to test some things on various versions of Java, to play around a bit. And also the examples that I created, they use Docker to illustrate how things work, so that you don't have to install all the various JDKs yourself. So even if you're not familiar with Docker, I think it's relatively easy to work with. We specify which version of Java we want to use. In this case, Java 17. We want to use Maven because it's a Maven project. We add the source code for our application. And then in the end, we run the Maven test goal. And we want to fail at the end because we want to see all the detailed information, even if some things failed in between. If we want to build this and make sure this is being run, we can use the docker build -t, and we give it a name. And don't forget the dot at the end. The dot specifies the context, in this case, the current directory. So if you forget that, it doesn't work. So this is an easy way to try out new and cool features with Docker. So basically, we start with a local machine, then the build environment, and then we move move over to the various other environments, such as the test environment, production environment, staging, etc. Yeah, again, if you upgrade from like Java 8 to Java 11 or from 11 to 17, it can be a bit of a challenge. If you encounter an issue, you don't know which version of Java caused the exact issue. If you upgrade from 8 to 9 and you have an issue, you know that's caused by Java 9. So you can Google for that issue in combination with Java 9. And in general, you can find a lot better information based on that than on more general search terms. So it might be a good idea to gradually upgrade and not go from 8 to 17 at once. That might be a bit of a challenge to figure out what issues are being caused by what version of Java. So for the ingredients, it's important, I think, that you start with a proper IDE with support for the latest Java version, so that you already in your IDE can fix most of the issues with a short feedback loop. But also make sure that you upgrade all your compiler plugins and the compiler and build tools themselves, because else you might still be running on an old version of Java, or some parts of your build might be running on older versions of Java. For Maven, it's fairly simple. You have the Maven plugin for Java, and you can specify that you want to use release 17 in this case, and then Maven runs everything on Java 17. Of course, you need to have Java 17 installed for this to work. Yeah, for me, upgrading dependencies is something that's always important, not only if you want to upgrade your Java version, but it's important to keep them up to date for security reasons as well, but also to use cool new features and performance improvements and bug fixes and things like that. I, in general, recommend to upgrade your dependencies on the current version of Java, so that you can see if something is caused by the dependency upgrades or by the Java upgrade. Once you have upgraded all the dependencies on the current version of Java, you can migrate to the new version of Java and then see if everything still works properly. And as mentioned before, hopefully a lot of the challenges caused by the new version of Java are already resolved in the new version of your dependencies, which basically make your work a lot easier. Don't forget, if you have any libraries that you create yourself, don't forget to upgrade them as well. Make sure they're up to date as well. And make sure that you also check for new names for the artifacts and group names. There are plugins which you will see in the next slide to check if there is a new version available for the dependencies that you use. But it basically checks what's the latest version for the artifact and group names that you specified in your build scripts. However, if there is a fork or a new name for that specific dependency, then those plugins won't notice that because the name is different. So if you have some dependencies which are fairly old and not updated in the last couple of months or years, it might be good to check if there isn't a new version available under another name. So if you quickly want to see what the latest versions are for the dependencies that you currently specified, you can use these Maven and Gradle plugins and incorporate them in your build to see what's going on and upgrade everything to the latest version. So after we upgraded everything, I think it's important to do things step by step. So don't try to do everything at once, because one change might impact some issues that you encounter in the next phase. So for me, the best approach was to first see that everything would compile again, all the source code would compile again, then that all the test source code would compile again before running all the unit tests. Often, if you have all the compilation stuff working, then also your unit tests start working automatically again. Sometimes you need to do some upgrades for the unit tests as well, make some fixes there, but in general, making sure that everything compiles is the big first step. After that, it's a matter of packaging and testing if the application runs to see if you have any runtime issues, maybe caused by some dependency conflicts where multiple versions of the same dependency are being used by your application, but in your resulting artifact, only one of them will be used. So if that one doesn't contain methods that are available in another version, then you might have some challenges. So if you follow this recipe exactly, you might have a nice pizza at the end or a nicely running build. However, sometimes that's not possible. I've encountered situations where I wanted to update all the dependencies on the older version of Java, but then noticed that some of my dependencies actually needed a newer version of Java. So I first had to upgrade Java and then upgrade my dependencies. So it differs a bit, but in general, I think it's good to have a bit of a structured approach and see if that works. If it doesn't work, you can always deviate from that. But then often it's a bit more of a challenge because you're upgrading multiple things at the same time, and then you don't know what exactly caused which issue. So now we're basically going to look at various Java versions and what's changed in those Java versions. So what you have to do if you use these features in your application, what do you have to do? In case you use JavaVex, you can use the GlueOn build for it, or you can use the Maven dependencies that are provided. But one thing that's interesting and a lot of people aren't aware of is that you have OpenJDK and you have the specification which specifies what's in the various JDK builds. However, there are also JDK builds who have more features than just the specification. For instance, Liberica has a JDK build with they call it the full profile, and it contains everything in the specification and some extra stuff, such as OpenJFX. The same goes for the OJDK build. It also contains a few extra things that are maybe removed or were never incorporated in some of the other JDK builds, but they are in there. So it's an option to use those if you want to have those features and you don't want to use any of the other alternatives. One other thing that a colleague of mine came across is that the JDK fonts have been removed. So the JDK itself contained a small set of fonts, not a lot, just a small set. And those fonts could be used by the application directly. For instance, if you use something like Apache Poi to work with Office documents like Word or Excel documents, that would use some fonts, and it would use the fonts provided by the JDK if they are available. If the JDK didn't provide them, then Java would try to find the fonts on your operating system. However, if you use a really small operating system, for instance, an Alpine Docker image without any fonts installed there, then it might break because the JDK doesn't offer the fonts anymore, and the operating system doesn't offer them as well. So then you need to install the font config and optionally the various fonts that you need to use in your application. And then you're good to go again. One other thing that was removed was Java Mission Control. Java Mission Control is an application for profiling and monitoring your applications with really low overhead, like only a few percentages. And it can be used on production as well. Before it was actually a paid version. You had to pay if you used it on production. Nowadays, it's a free version. And I can really recommend to look into it if you want to do something like profiling. Personally, I liked it a lot better than things like Visual VM, for instance. If you want to use it nowadays, you can find builds on the Adopt OpenJDK and Oracle websites. Something to keep in mind is that it's no longer called the Java Mission Control, but the JDK Mission Control. So if you Google for it, you might find results on both names because it's a bit confusing and not everyone is using the right naming yet. I think the biggest challenge and something that almost every project will probably need to do something about is the removal of the Java EE and Corba modules. Probably not the Corba modules, but the Java EE stuff is being used in almost any application. For instance, Devoxx BE is used all over the place, but it's no longer part of the JDK itself. And one other thing that's changed is that it's a Java EE module, and Java EE is nowadays part of the Eclipse Foundation, and they renamed everything. So it's no longer javax.xml, blah, blah, blah. It's jakarta.xml, blah, blah, blah. So this is one of those cases which I mentioned before, that you have to be careful that you have not only the latest version of your artifact, but also look at the name of the artifact. Do you have the latest name of the artifact? So in this case, the old one stopped development in 2018, and under the new name, they continued development. So what do you need to change in your application? You need to change your import statements, and you need to add a set of dependencies. Which set of dependencies is it? So this is a lot of information. The most important points are in the column on the right, the new artifact IDs. So for a lot of Java features, activation, annotation, transaction, JavaOne BE and JavaWS and Corba, those are removed, and you need to do something to replace them. For Glassfish, there is not enough. For Corba, there is not an official replacement, but there is a Glassfish version which you can still use. One thing to keep in mind here is that for JavaOne BE and JavaWS, you need to add 2 dependencies to your application, one for the API and one for the implementation. The others simply can be used standalone. So this is something you will come across most applications once you upgrade from, for instance, Java 8 to Java 11. At Java 15, they removed the Nashorn JavaScript engine. It's something I came across in a couple of applications where they used Nashorn. You can still use it, but now you need to add a dependency, just like for the Java EE modules that were removed in the other version of Java. For Java 16, there was one big change, and that was that some of the JDK internals, so some lower level APIs in the JDK, they were encapsulated so that you can no longer use them. The JDK developers don't want you to use those internal APIs, they want you to use some higher level APIs. And that actually caused some issues for instance, Lombok. Lombok uses really low level APIs because they do all kinds of things underwater. Easiest thing to fix this is to use new versions of your dependencies. For instance, Lombok released a new version within, I think, 1 or 2 weeks after Java 16, and there it was already fixed. If you use internals yourself of the JDK, or if you have dependencies that aren't upgraded quickly, there is actually a workaround. You can configure the Maven compiler. This is the example for Maven. And basically what you can do is you can open up everything that was closed down. And this, of course, it feels a bit weird. Someone put a lock on a door and you remove it. It's not something I would recommend. I recommend that you change your code base and your dependencies to use a bit higher level APIs instead of these low level APIs. However, if you need it, you can actually still use these. This was also where I encountered the issues with the Maven toolchains plugin. So I tried to use Maven toolchains to specify that I wanted to use Java 16. And then when I run the example with the old version of Lombok, which failed, I basically got this error. And I don't know about you, but for me, this error, it's pretty useless. It basically says compilation failed. It didn't give any details, so I had no idea what was going wrong. Then I tried to compile it without Maven toolchains, basically installed Java 16 directly and ran Maven on top of that. And I got a way more descriptive error. Basically, it says that a class cannot be accessed because some module doesn't export it to an unnamed module. And that's exactly what we saw a couple of slides back, where we opened up those modules again so that we could use them again. So for now, the tool chains didn't really work nice for me, but I still think it's a really nice feature if the bug is fixed, to use that to work on various versions of Java with your code base. In Java 17, it's not completely clear what will be added or removed in Java 17. That's still under development. But a couple of things are already known, and that's the applet API, which will be deprecated. I hope you no longer use applets, although in the session I gave earlier today, I heard that some companies still use applets with old versions of browsers because new versions of browsers don't even support applets anymore. But that will be removed in one of the future versions of Java. For now, you're still safe, but yeah, you should get rid of them basically. One other thing that's being removed is AOT and JIT compiler experimental features basically. And that's basically part of GraalVM nowadays. So if you want to use that, simply use GraalVM, and you can still work with things like this. So basically, then we're done. Basically, we finally made sure that we're on the latest version of Java. And to dive a bit into that process, let's have a quick look at some of the examples that I have in here. So that you can also play with it if you want and then try out some things. So for Lombok, I have two examples, the Lombok broken Java module or Maven module, which uses the old version of Lombok, and I have a fixed one, which uses the newer version of Lombok. Now I can run the code for that, Java 16. And I think it's this command. No, that was the wrong one. Let's quickly grab it from the README. So this is a bit longer command. Basically, I make sure that I cache some things, but some things shouldn't be cached, so that I can actually display it for you. Basically to speed up the process, else you have to wait for all kinds of Maven updates, which probably you're not so interested in. I see some of the caching didn't work completely. Of course, with a demo, something should fail. But you don't need to use things like these disable cache arguments. You can use the Docker commands I supplied earlier, but then each time when you run it, all the Maven artifacts are being downloaded again, which for some reason now also happens. Maybe because I made a change somewhere in my code base, because that also triggers a new build. Luckily, it is fairly quick. So basically, I ran the examples on Java 16, and I can see that the Lombok broken one failed here. That's expected because, yeah, the internals of the JDK are no longer available here, and we still try to use them. If we run the same example on Java 15, of course, why not? We download everything again.
It must be the curse of Maven coming to get you. So I can ask you a question in the meantime.
Of course.
Yeah, one from Jfokus here. So he says SQL Server 2019 now supports Java, but Microsoft and Azure Cloud Support for SQL Server promote a JVM JDK called Azul. How does it compare to Oracle's Java 16 or 17?
That's a good question. And so before, I think the entire world was using the Oracle JDK. There were some alternatives, but I think 90% used the Oracle JDK. Nowadays, there are a lot of alternatives. So there is the Oracle JDK, which is a paid JDK. You have the Open JDK, which is also maintained by Oracle and some other organizations. Next to that, you have things like Adopt Open JDK, Liberica JDK, and the Azul JDK. Basically, they all support the same features that are part of the specification of Java, but they might have small tweaks. So they might have some performance improvements, or they might have some extra tooling or extra support around it. I personally haven't used the Azul version yet, but I've worked with Adopt OpenJDK, the Oracle JDK, and the OpenJDK, and in general, applications run on each one of them. It doesn't matter too much, but you might get some improved performance if you use one that has support for that. And there are also paid versions. I think Azul as well has paid versions of the JDK, which might be even faster or offer longer support on various Java versions. So I think it's a matter of seeing, what do you think is the best version? Do you want to pay for support? What features do you need? And based on that, make a decision which one fits best for your use case.
Cool. All right, I'll drop off and let you get back to it.
Yeah, thanks. So on Java 15, we see that everything is running smoothly, of course, because the internals are still available in Java 15, so it's not an issue. So feel free to play around with these, and if you have comments to improve these examples, or if you have even more examples, please let me know so I can continuously keep updating the README, which will hopefully help a lot of projects in their migration to newer versions of Java so that they can focus on specific challenges for the application instead of generic challenges that occur in most of the applications. So now actually we had a bit of the tougher part, and now we can use cool new features such as Java records and the pattern matching features, have the improved security, hopefully also improved stability and performance. So basically now the real fun can start. And if I can give one tip, basically make sure that you just get started with the upgrade. Don't talk too much about it. I had a discussion within the company when I joined this company. And they asked me if I could give an estimate for every application, how much time it would take to do the upgrade. Yeah, I mean, that's quite impossible because I don't know how quick the other colleagues of all the teams are. It's hard for me to even estimate how much time I would have to spend myself. So I told my colleague that once I finished all the migrations, I would give him the estimates. And luckily, in this case, they agreed and gave me time to do the actual upgrades. And I did upgrades one by one, so I could also show the progress, because that's something important. If you spend weeks on one upgrade without being able to show progress, and then it's hard to keep motivated yourself, but also that the business and the management who decide on your time keep the motivation on a good level and keep allowing you to spend that time. So make sure you make small steps that you can show that the build maybe is passing on a build server, that maybe the tests are working. Do it step by step so that you can show progress for yourself and for everyone around you. And that was basically it. Again, if you have any questions, feel free to ask them now, contact me later, and have a look at the Java upgrades. And in between, I also try and make sure that I share the links that I have in the chat.
Oh, Inception, I like it.
I'll put it on another screen. That's probably better.
Yeah, if you can put them in the chat, then I can share them on the screen so people can see them and people can click on them and all that.
Yeah, I think I cannot post something because I'm not logged in or something.
Oh, no, you actually have to go to YouTube, right? So youtube.com/DenverJug, and then you'll be able to like you or whatever. If you post some in the private chat, though, here, I could grab that too.
I can go to the YouTube as well. Let's put it there.
If you post some in the private chat, though, here, I could grab that too.
I can go to the YouTube as well. Let's put it there.
We got the echo.
Private chat though, here, I can grab that too. I can go to the YouTube as well. Let's put it there. It's too much at once.
All right, you gotta mute the video on YouTube there.
Oh, sorry for that.
Okay.
I have to split it up a little bit because apparently I cannot post so much stuff at once. So
Well, I'll take your presentation off here, and I'll add the other folks back in, and we'll have a bit of a chat at the end here. So, Greg, Chris, you got any questions for Johan?
No, it was
How are you
great.
guys?
I think the best thing was your advice about showing incremental progress. I think that's something that we often forget about in all the work that we do. And
Yeah.
just for ourselves, for motivation, I found it's good for me too to chunk things. Things are much less overwhelming.
Yeah, this was great. I like the incremental approach. I do have stuff that's the 8.0 that needs to be updated a lot, and so tackling that could be challenging. Just an FYI for everybody that follows the Twitter feed or any of our social media stuff, I did post the link to the Git repo, but I don't think the deck is in there, so I just need to post a link to the deck.
I just posted a link to the deck as well on YouTube.
Awesome. Thank you. Thank you for doing this, especially at 1 in the morning.
Yeah, no problem.
Yeah, we appreciate it, and I'm looking forward to Java 17. I mean, there's I don't know. Do you know if Project Loom is going to be a part of 17, or if that's a separate thing?
Yeah, from what I heard is that it's not completely finished yet, so I guess it won't be part of it yet. Java 17, it's almost already September, so I don't expect that many big new things will be added. But yeah, we'll have to see. Maybe they will put some progress in it quickly and manage to fix it. It would be awesome if they do something like Project Loom already. That would be a major feature.
Yeah. So for those who aren't aware, Project Loom is a way of making, from what I've heard, a lot of its authors say that reactive won't need to exist anymore, like reactive programming, because Project Loom will handle that. The threads will be cheap and all that. So I think it's a good battle we got coming up with like the Spring and the Scala folks and all those folks to be like, okay, can Java have a comeback with synchronous programming, or do we continue doing asynchronous? I think, yeah, who knows? It'll be fun.
Would make life a lot easier.
Right. Yeah, for sure. So we'll let you get some rest, and thanks for joining us again, and enjoy the rest of your week, y'all.
Yeah, you too. Thanks a lot for having me, and have a nice evening.
Good night, everybody. Thank you for joining us.
Bye.